what I have at the beginning of most of the packets, not all the packets, but at the beginning of most of the packets, I'll have some vocabulary. And the vocabulary is there because some of you may recall from junior high or from elementary school some of these terms, and some of you may not. But I want to make sure that they're there. What I don't do on the test is I don't have a matching like, okay, here's the word mixture, I've got all these terms and definitions, you match it up. I don't do that. However, in the questions, I use these questions, so in a question, or I use these words within a question, and I expect you to know the meaning of it. So that's why I usually give the definitions at the beginning, so there's no questions, there's no content there, that's just more of a dictionary thing at the beginning. So turn the page. Okay. And you'll notice that I have the blanks already filled in there for you. And one of the things about chemistry, and you may or may not have known this when you first signed up, but you're actually taking a math class. Some of you are like, what? That's why I said make sure you get a calculator. Because with chemistry, you're actually bringing together not only the science, but also some math. Physics is also more of a math class, but physics is definitely a lot more math than chemistry. If you can do basic algebra, you'll be in good shape, okay? And if you're weak at algebra, I'll teach you some tricks that will get you there. So there's some nice tricks that your algebra teachers, I'm pretty sure, haven't taught you. So it's pretty nice. But we have to use math for chemistry and for physics. Not so much in biology, a little bit in environmental, okay? But definitely with chemistry. So that's why I want to make sure that your math skills are somewhat strong. I mean, they don't have to be Herculean strength, but the worst thing was to get you to recognize that when you see something as a surprise, your brain can't comprehend it or doesn't capture it. In other words, there are certain things that take place that you think you see, but your mind filled in the pieces. It's really bizarre. So if you're a good scientist, you're going to make good observations, or if you're going to be a good whatever, good official, whatever. Here's some things that we can worry about in chemistry. Measurements. Measurements describe things like length, mass, temperature. One of the things too that I'll also talk about as we go on the whole year, in math class, you typically don't ever include units. You don't ever do that. However, with chemistry, we have to include units because we're trying to convey or express something, some value to somebody. Okay. So like for example, I could tell you that I weigh, what is it? It's a little under, it's about 115 now. I think I weigh about 115. What are you laughing at? Calling me fat? What? Should I weigh more? What am I expressing my units as? Not pounds, that's why you're giggling. Kilograms, okay? So I didn't tell you, but we are all conditioned, and that's sometimes when we do our homework, I'm like, well, everybody knows what I'm talking about. I don't need to write the units down. But if I tell you, and again, I'm kind of a big boy, but I have run 3 marathons, over 33 half marathons. I'm a big runner. My category is called Clydesdale. You like that? They got the runners and then the Clydesdales. So, yeah, that makes me feel good. That's a good confidence builder. But I get her done. All right, I can go out. Yesterday, went out and ran 4 miles. No big deal. It's okay. Condition your body to do that. However, what we do is make sure that we actually include units so the numbers have meaning. If we don't put units on there, you're just in a regular math class and you're like, oh, just add 2 plus 2. What is that? 4. For what? Well, in here we have some interest in knowing what that is. So no naked numbers. I don't know if I have that anywhere in here, but that's a good visual. No naked numbers. So that's what that's referring to. A number can refer to anything. It's not until you put a unit on there that it has some significance. Also, only like quantities can be added and subtracted. You may have never thought of this before. But if I ask you to solve for this, I have 12 feet minus 3 pounds. That equals? It's like, what? Again, that should make no sense to you because we have a unit that is a length and a mass. So we have to subtract or add like quantities. Okay? So yeah, we're never going to do that. Scientific notation. Hopefully you have been exposed to scientific notation in the past. If you haven't, that's fine. It's rather easy. Whatever your number is, move the decimal place over, depending on if it's a large number or a small number. We'll do some examples here. Move it over so that you only have one value, and then a decimal place, and then two values after that. And then how many times you move the decimal is your exponent. So if you're moving your decimal this way, is your exponent going to be positive or negative? Positive. And if you move your decimal this way, it'll be negative. Okay? That's pretty simple, we hope. And when we start working with some large numbers, and we'll work with some big numbers in here, because again, atoms and molecules are really small, so when we start talking about, if I were to ask you how many atoms we had in here, there's a lot. Quite a few. Okay, so we don't want to write our numbers with a bunch of zeros, and actually the number of atoms in there is a lot longer than that. So I'll talk about the exponent button on your calculator once we start doing this. And like always, if you have questions about your calculator, okay, and again, while we're doing the homework, while we're working out problems, ask me. I'm not a professional on calculators, but I'm pretty good. I've been around the block a few times. I'm pretty experienced on being able to help you there. All right, let's do some practice problems here. Okay, and what I'll always do is I'll give you some practice problems and then give you some homework, so it's not like, oh, what in the world. So if I asked you to write this guy over there. Sorry. What did I do? Crap. Ooh, smartboard is okay. Just screwed that up. All right, so if I want you to write the numbers using correct scientific notation, how would I write A with the correct scientific notation? Here, I'll start you off. 8.3, is it 7? Yeah. 7 times 10 to the what? Did I hear a 10 out there? 10. I'll buy a 10. That's good. Okay. And again, what I did was, here's my decimal. So I moved it 3 places, and I normally don't put commas on here, but I did it so you could see it really easily. There's 3, 6, 9, and then go one more. So I moved the decimal 10 places. Okay. For B, how would I write this? And don't be shy. Again, I don't have a teacher's manual up here or an answer book, so you guys are the answer. Yeah.
4.53.
4.53 times 10. 8, I like that. And it's because I moved my decimals 8 times. And again, if I move it to the right, my exponent should be a negative value. If I move it to the left, it should be a positive value. In other words, your goal should be to make this much money in your life, not that much. Okay? That means you're in debt. That stinks. Okay. So we want to make a lot of money. All right, so C. Ooh. 2.0, I'll get you started, times 10 to the 0. Very good. Good job, Brody. So again, I did not move my decimal place. And as a quick check, see how many of you are smart out there. Anything to the 0 power equals 1. Very good. And again, so you can type this on your calculator. 125, and then power 0 equals 1. Okay, so anything to the 0 power equals 1. It's all right. At least you're all on the same bus. Get you going. Okay. Letter D. So 8.33 times 10 to the -3. I like that. Good. Okay. So you think you could do the ones there? The answer is yes. Oh, and if you need to, you can click there and check the answers too. They're on there. Okay. All right. So the homework is part of that. Oh, here we go. SI units, metric system. In science, it's good to be the world power. Don't get me wrong. Okay. Being in America really is a nice thing. I wouldn't want to be anywhere else. I've been to Canada, and that's all I've been so far. I'm not a world traveler, but I know it's good here. Yeah. So, since we're the world power, we still use stupid units like pounds, miles, inches, feet, all those stupid things. For whatever reason, I don't know why we get away with it. But in the scientific community, we have adapted with the world in that we use metric. And we're trying to sneak it in. Where are some examples of some metric that you use every day? You may not realize it. Technology. Technology has been using the metric system ever since its inception. Like, and you're probably way too young for this, but kilobytes, you all know megabytes, you all know gigabytes, terabytes, okay? Those are all metric prefixes that deals with how many times a byte is how many times you press on a keyboard. Did you know that? Okay. It's all old news. So when we talk about the metric system or the, and I'm not French, so I'm not going to say that, the international system is what that is. When we talk about length, we're talking about meters. Talk about mass, talking about kilograms. Hey, nice thing is time's still time. That's good. Temperature, don't worry about kelvins yet. That'll actually come into play next semester. And you'll like this. If you want to abbreviate mole, which is an amount, which we'll talk about later, you drop the E. Isn't that awesome? However, you don't really care about those just yet. What you really care about are the metric prefixes. Okay. And do you guys have this blank here? The same link? Oh, whoa, easy. Okay. Now you see all these metric prefixes here? Did everybody get that blank, same link above that? Okay. These metric prefixes, I want you to have memorized by the next time we meet. Think you could do that? Think you can? I'm willing to bet money that you could have this memorized, what is it, 9 or 8:35 right now? Who wants to bet me? I bet somebody could have this memorized by 9:40. Anybody want to bet?
Yeah.
Brody, you will know this by 9:40.
So, like, what do you want me to know? Like,
This whole thing. Like, I want you to know the values. Whoops. I want you to know this. Okay. This will come into play, but know these two columns here.
Alright.
Okay.
Wait,
You got it?
which two columns is
The left and right column.
Oh.
Okay. You got it? Can you do that?
Yeah.
While Brody's trying to do that, let's all do this. Okay. You still have your thing in front of you. Brody's crashing here. He's going to burn if he tries to do it on his own. But I bet the rest of you will have it by 9:30, 9:39. Brody, it'll take him an extra minute. All right. Maybe not. Okay. Here's a great way to remember all the Greek prefixes. No, go away. Okay. There's a story, and a former student of mine gave this to me, so this is not mine. And he's actually at the University of Michigan right now finishing up his dental degree, so he's going to be a dentist. I don't know why anybody would want to be a dentist, but whatever. Think about it. Would you want to go digging in somebody's mouth? That is disgusting. I'm burning time, but it's okay. So this kid actually told me this story. It's great. He said, the great mega king one day caught me microwaving nasty pizza. The great mega king one day caught me microwaving nasty pizza. The great mega king one day caught me microwaving nasty pizza. Okay? And then he said, just like what we said a second ago, since this is a metric system, everything's base 10. Okay. So anything to the 0 power is 1. Nice. So 10 to the 0, which doesn't have a prefix because we'll be using like meters, liters, and grams. And they don't have prefixes because if I go 1 meter, I don't need a Greek prefix to express 1. Or if I have 1 liter of coffee, which I don't drink, that'd be a lot of coffee, I don't need a prefix for that. But there are certain things like milliliters. That's the most common thing that we're accustomed to. So we have our 10 to the 0. Now, if we go to the right, we'll have negative exponents. If we go to the right, we'll have sorry. If we go to the right, we'll have negative exponents. If we go to the left, that's all right, my wife's a kindergarten teacher. Go to the left, then we'll have positive exponents, okay? So we know that deci is 10 to the negative 1, and cente is 10 to the negative 2. Okay, so we got 0, negative 1, negative 2. Now, here's for the fun part. From here on out, it goes 3, 6, 9, 12. 3, 6, 9, 12. 3, 6, 9, 12. A great mega king one day caught me microwaving nasty pizza. 0, 1, 2. Again, start with the 1. 3, 6, 9, 12. So we got 10 to the negative 3, 10 to the negative 6, 10 to the negative 9, 10 to the negative 12. 10 to the 3, 10 to the 9, 10 to the 12. What? No. Oh, wait. Whoa. This is bad. I'm wasting time. 10 to the 9, 10 to the 12. Okay. So the great mega king one day caught me microwaving nasty pizza. 0, negative 1, negative 2, 3, 6, 9, 12. Brody, you're up.
All right.
Nope. Come on up here.
All right.
Do it. Write it. Oh man, we're gonna be early. And you can pick any color. Oh, whoa, no. Grab a pen. Have you ever used a smartboard before?
Nope.
I've only been using it for, and you get to pick whatever color you want here. You,
This has like multiple colors.
well, you gotta choose. You get to pick.
I want blue.
Blue? All right.
Just write all the things. Right?
There you go. King. Oh, no, I skipped the 1. You don't want to put the 1 in there?
Oh, well.
Use your eraser. You got an eraser. Look at that. Don't worry. You'll all have a chance to use a smart board. Does anybody have smart boards in the lower grades? Really? These things are everywhere in Plainfield. I live in Plainfield. That's what I like. Caught me in the little, it looks like a kind of a U-ish thing. That's what the symbol for micro is.
Okay.
Just write a U. It'll be all right. And then we'll no. Is that great? No.
Alright, then there's Millie.
No. What? No, we're not doing Millie. We're just doing this. The great mega king one day caught me
Honey making.
microwaving.
Yeah, microwave. Yeah, so the micro would be.
Come on, man. We got like 1 minute.
Micro.
No, micro, little U. Again, that is the hardest one because it.
Making. Microwave.
Nasty.
Oh,
Nasty.
Oh. Nasty pizza.
Nice, nasty pizza. All right.
And then I got to do this.
Oh, start in the middle.
Sorry, in the middle.
You can change your color. There you go. 10 to the 0. 10 to the negative 1. 10. Now make the magic happen. Okay, so don't freak out on something like that if you make, what is it, a mnemonic saying? I don't know. I'm not English. Did I do that right? Is that a mnemonic saying? Okay, good. As long as we're all in the same boat, that's good. Okay, so, very nice. So don't freak yourself out when you see material that great or that much, and we'll get used to it. And the micro, I do something like that, kind of like a pointy U with a tail at the beginning. I don't know, it's a Greek letter. So, okay, so, and then if you want to memorize it that way, that's kind of more like what we just did. The great mega, again, the great mega king. One day caught me microwaving nasty pizza, and then go 0, -1, -2, 3, 6, 9, 12. Okay, so we'll get a chance to do that. Also, let me ask you this: if I'm comparing two things, let's say mega and centi. If I had 1 megagram, actually 1 megameter and 1 centimeter, which one's bigger? Megameter, right? So things this way are bigger, things this way are smaller. Make sense? So here's some practice problems. Excuse me. Which of the units in each of the following pair represent a larger quantity? Kilometer or centimeter? Which one's bigger? Kilometer, yeah. For those of you who run, I think you'd rather run a 1 centimeter race than a 1 kilometer race. Okay? A picoliter or a milliliter? Milli's bigger. Good. Even though it's really small, it's bigger. Megagram or microgram? Yeah. And again, these are two different M's. Capital M, lowercase m, and then there's meter, which is another little m. Too many M's. Did I do megagram already?
Yeah.
Or I skipped? Oh, I did. There was only 3. My bad. Which one is a smaller quantity? A nanometer or a centimeter? Nano is smaller than centi. And microliter or milliliter? So micro versus milli. Micro smaller. Good. Micro, milli. And last one, centigram or kilogram? Smaller. Centi. Good. Okay. So not too difficult. I think I might even ask you some more on there. Okay. All right. We're cooking. Uncertainty in measurements, and the 2s are part of your homework as well. So far, I think you have about 4 minutes of homework. Whenever a measurement is made by a device, this would be a graduated cylinder, one of these things, and we'll get to use some of these here shortly. We have to guesstimate on some readings, okay? But we always write down what we know, for sure. And then we don't want to do something like, here's what I would not do. I would not look at this and go, that's got to be, well, let me ask you what you think it is first. If you were reading this, do we read it, and this is what's called the meniscus, okay? Do you read from the bottom of the meniscus or the top of the meniscus when doing that? The bottom. Good guess. It's 50-50, good odds. Okay, so we know that we have at least how much in here? What are we certain of? Yeah, we know we have at least 30 milliliters. Is it safe to say we have at least 35? Okay. So it's safe to say that we have at least 35. Can we say for certain that we have 36 or 37? No. So since we don't know what this value right here is, okay, that's our one uncertainty. We know for sure that we have 30 milliliters in there. We know we have at least 35, but really we're guessing when we say that we have 36 or even 37. Okay. Here's what you would never do. You would never look at this graduated cylinder, especially with those types of markings, and go, yes, that's 36.75873 milliliters. Duh. No, there's no way. I mean, we're guessing on this value right here. So when we go and write more decimal places on here, you're just throwing garbage around. There's no way you could prove that those actually exist. So we write down what we know for sure, and then we write one uncertain number. So I know there's at least 30. I know there's at least 35, but I'm really guessing if there's 36 or 37. And guess what? I would accept 36 or 37 on that. I might even go out on a limb and accept 38, but you'd have to really impress me on that one. Okay, so whenever we read instruments that are not really well marked, don't go crazy and try to tell me what the values are there. Okay, that's what all that was talking about. And that gets into significant figures, which you guys are going to absolutely love. You guys ever worked with significant figures before? Ugh. Oof. Everybody have the blink so far? Alright, significant figures or Sig Figs. Significant figures is a way, it's a means by showing that the numbers that you're writing down actually are important, or they have relevance. Okay, just like with that example with the 36 point whatever I wrote down. The point whatever has no relevance. It's just, that's what my calculator gave me, all right, or something like that. No, don't write down too much stuff. And just because your calculator spits out a value that goes all the way across the screen, don't write every number down. Okay, so we're going to talk about significant figures. We've already talked about certain digits in a measurement plus one in a certain one. That's cool. Okay, we'll use that only in the lab. But we also want to be able to look at a value and ask yourself, hey, how many significant figures do we have? Any number, if I gave you a number, okay, or it's on your homework or something, if it's a number that's other than 0, it is significant. So like for example, the number 96, there's both of those numbers are non-zero numbers. So both of those are significant. 61.4, all those numbers are significant. However, that 0 in front of the 0.52, I'd be willing to bet that probably half of you would only, whoops, that's my habit, sorry. I'd be willing to bet that half of you probably would only write that. And you know what? That's fine. This is just eye candy. Okay? It really is. It has no significance. It's just there because I like it. Okay? Some of you like it, some of you don't. That's why you don't show it. Okay? So that 0 is not significant. Okay? When you anything that is following a decimal point, okay, and there are trailing zeros, they're always significant. So in other words, what you want to do is look for the decimal and then ask yourself, okay, is there a non-zero number before my first 0? And this is where it really gets fun and confusing. Since these are all non-zero numbers, you have 3 Sig Figs. Since I have a non-zero number here and here, these zeros are significant. This is probably where you're going to come back and look at the video. Since I have a decimal place here and I have a non-zero number to the left of a 0 for the decimal, those are now significant. Also with that one as well. And you're like, what? It gets better. We'll do some examples here in a second. Captive zeros are always significant. However, zeros that do not have a decimal before the non-zero number or even a decimal are not considered significant. This is crazy. Since there's no decimal there, only the 7 is significant. These zeros are simply placeholders. Since there are no non-zero numbers before this 7, there's only 3 Sig Figs. These are only placeholders. Okay? You're like, what? So just remember, if there's a decimal, now they're all significant. No decimal, then only the non-zeros are significant. Aren't you glad you got out of bed this morning? This is what drives my students nuts. Even AP students go crazy on this stuff. Exact numbers. Okay? When we talk about an exact number, we're talking typically about conversions. So like if I say, oh, how many centimeters are in 1 inch? How many centimeters are in 1 inch? Does anybody know? I'll always give it to you, but I'm just curious if anybody knows. I heard 2. Yeah, you got one of the numbers right. 2.54, yeah. So there's 2.54 centimeters in an inch. And don't stress out, I would give you that conversion. Those are considered exact numbers, and we would never use those values to determine significance. Oh, there it is right there. Sorry. All right, now for the fun part. Multiplying and dividing with Sig Figs. Oh, Lordy. Anytime you multiply and divide with significant figures, you're going to run your whole calculation through on your calculator. And then you're going to look back at your values and ask yourself, okay, which of these has the least number of Sig Figs? Whichever of the numbers that you're given. I'll do an example here in a second. And that value will tell you how many significant figures are in your answer. Let me see if I have one. I don't. But let me use this open space. Let's say that I have 7,324, and I'm going to multiply that by 20.1. Okay. So if you have your calculator, type that in. Let's see what you get. So 73.24. That'll give you a chance to use your calculator. In my calculator, spit this number out. 147 point. Oh no, that's a comma. God, I hate that function on there. 212.4. Okay. So that's what my calculator spit out. When you multiply or divide, and I'm not doing a division here, but it's the same principle. This is what my calculator spit out. What would I write on my paper? Well, you want to look at these two values. Ooh, what happened? How many Sig Figs are in this top bag? 4. Very good. How many Sig Figs are in this bottom bag? 3. We have a captive 0. So what you need to do is look at it and say, okay, well, there's 4 Sig Figs there. There's 3 Sig Figs there. So my answer will have how many significant figures? 3. Yeah, so you look at the two numbers, whichever of these two values, or however many values you're multiplying, you want to look for the one that has the least number. So on your paper, you would write either that, because there's only 3 Sig Figs in your answer. What's another way I could write that? And still only have 3 Sig Figs. Learned about it earlier today. Very good. And what would that be? 5? Okay. So either or. If you start having numbers with a bunch of zeros, you're like, I've written about 4 zeros here. Get in the habit of writing scientific notation. Okay. So again, when you multiply or divide and you're looking for significance, look for the value that has the least number. Again, this one has only 4 Sig Figs. This one has 3, so my answer will have 3 Sig Figs. Okay. Make sense? It's not too bad. I think multiplying and dividing is actually easier. All right, so let's look at adding and subtracting, since I said that. All right, when you add and subtract, and you're concerned about significant figures, you do the math, you add them all up, or subtract them, or do whatever when you're adding or subtracting, and you want to look for the number with the least number of decimal places. So it's all about decimal places when you add and subtract. So for example, and that's how many decimal places your final answer will have. So if I have like 23.47728, and I have, and that's added to 17, well, my calculator is going to spit out 40.47728. That's what my calculator is going to spit out, if I did that right. What am I going to write down as my answer? 40. Okay. You can either write 40 or 40 with a point. Either one of those would have been correct, because they had the same number of decimal places. When you add and subtract, you look for the value that has the least number of decimal places. Since that one doesn't have any decimal places, there shouldn't be any decimal places in your answer there. Okay. All right, so let's look at some of the practice problems here. Practice problems ask how many Sig Figs, or how many significant digits are in each of the following quantities. In A, how many sig figs? 1. Okay, remember that if there were 2, there'd have to be a decimal to capture that 0. How many sig figs in B? 3. Very good. How many, without doing the math, how many decimal places should be in our answer? 2. Very good. So recognize that we're adding and subtracting, or adding and subtracting. So our answer, whatever the answer would be, would have 2 decimal places. How many decimal places would we have, or do we have in D? Sig figs. Sorry, sig figs. 5? Did I hear 5? Yeah. Good. How many in E?
9.
All of them. Good. Is that 9? Yeah. In F? 3. Excellent. How many in G? All of them. Good. So 11. Everybody get that? Isn't that good? So you'll have some of those in your homework. All right, the last thing, and this will be really quick, so we'll be done here shortly. Precision and accuracy. We often, and you'll use it much better now after today, we use precision and accuracy so interchangeably in our everyday conversations, if you use precision and accuracy, that it's brutal. And I'm going to tell you why precision and accuracy are actually different. Okay, so there's a little story that I have on there. Let me find an open space. Here's a good one. Let's say that I have 2 targets. I don't know why we'll do that. Okay. Okay. So I've got 2 targets, and I've got a BB gun, or a gun, or whatever it is. I don't know why I'm looking at this, but I've got a gun, and I'm looking at the left target, and I'm an excellent shot. I can't hit the broadside of a barn with a gun. So I fire off 3 shots. Pow, pow, pow. And they hit right here, right here, right here. Okay? I give the gun to somebody else. They line it up. They're focusing on this center spot right there. That's what they're aiming at. And they fire off 3 shots. And much better. They're hitting boom, boom, boom. Okay? Then they give it to a couple other people. And those same results keep coming back. What in the world's going on? Is the gun broken? No. But what? Sight's off. Okay? In other words, if I'm aiming here and I keep hitting here, the sight is off how? Up and to the right or down and to the left? Actually, up and to the right. So if I'm, like if there's a rabbit coming across, if I'm lining it up in my sight, and again, you can get used to doing this, and I'm not saying I hunt or anything, but if I'm tracking something and before I pull the trigger, I'm going to drop my gun, boom, fire. Does that sound like a really good way to do it? In other words, track it, knowing that your sight, if I'm aiming right here, I'll hit it here. So just follow it, and then before I pull the trigger, pull it up, I'll nail it. That's stupid. However, we have things in our house and in this lab that are very, very precise. In other words, when you get on your bathroom scale, if there's still bathroom scales around, we don't have one. When you get on it, I get on there and I'm like, woo, yay, whatever the weight is. I want to lose 10 pounds. You know how I can do that? Step right off, bend over, dial it back 10, woo, lost 10 pounds. Okay? So that everybody that comes on, woo, I lost 10 pounds. Everybody's getting the same results. That's precise. Okay? If I aim at the bullseye and I hit the bullseye, that's accurate. Okay? So we know where the center is, we know where the bullseye is, and we hit it. That's accurate. If we know where the bullseye is, but we're okay, knowing that we're only 10 pounds off, but everybody's 10 pounds off, this is also acceptable. Now, if you have equipment where you shoot here, 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 okay, then you need to look at the operator. Okay, so that's the difference between precision and accuracy. And I think, unfortunately, this is one of the longer lectures, so I hope I didn't bore you to death. But I think there weren't any. Oh, and percent error, I will give you this. We'll work this one out together. Why don't we save the 4s for when we come back the next time. So your homework tonight is the 1, 2s, and 3s. How's that? Since we get out of here in about 2 or 3 minutes. Okay. If you're an overachiever and you want to try the 4s, that's fine. But I'm only going to check the 1s, 2s, and 3s.